medieval Britain, only the church and the nobility could afford glazed windows. Magnificent windows like this were only found in cathedrals and abbeys. In these buildings, light was intended to be a spiritual as well as an architectural experience. The reality for the vast majority of the population was very different. Often living in self-built hovels, or if they were lucky, simple timber or earth structures, light and ventilation would have been provided by unglazed opening, sometimes protected by shutters. Vertical mullions gave a basic level of security. As the economy grew in the late Middle Ages, so did the demand for glass. In the burgeoning towns, glass-making and glazing techniques evolved. Although the front windows in this building are not original, those on the side remain virtually unchanged. The leaded windows were usually fixed into timber, metal or stone frames. Later examples, like this stone building of about 1680, had both fixed and hinged casements. Here, the opening part of the window, the sash, is formed in metal. This jetted timber-framed building from the same period has a series of simple wooden casements forming a large bay window. In the speculative developments of the Queen Anne and Georgian periods, the sliding sash window became the dominant form. The design was introduced from Holland at the end of the 17th century. Early sashes were built into simple openings. The photograph and plan show the exposed box frame concealed by an ornate cover moulding. Besides being stylish, sash windows are highly practical. They're easy to maintain and easy to clean, outside as well as inside. They also provide precisely adjustable ventilation top and bottom. The construction is, in fact, quite simple.
It principally consists of two softwood sashes contained within a softwood frame. Each sash is divided into a number of different sections by glazing bars. Each sash was divided into a number of panes, typically in this case 6, sometimes 9, sometimes 3. The reason the sashes were divided up was due to the limitations of glass technology of the time. Normally in double-hung sliding sash windows, the bottom sash would sit down onto a timber sill that would form an integral part of the larger sash box frame. In Bath, this detail was removed and the bottom rail of the bottom sash sat directly down onto the stone subsill.
In the late Georgian period, glazing bars became thinner and thinner. At the same time, windows were set back in the jambs. This provided better weather protection and better resistance to the spread of fire. A more refined appearance and further protection was achieved by setting the frames behind a masonry rebate. In the Victorian period, sheet glass became readily available. Glazing bars became a mere fashion statement, or even disappeared altogether. The popularity of the sliding sash window continued well into the 1920s. By the 1930s, their popularity was eclipsed by the hinged casement window. Fan lights, frequently leaded, were top-hung. The larger casements below were side-hung. Windows from this era are usually single-rebated. In other words, the sash sits in a rebate in the frame. Improved weather resistance was sometimes provided by anti-capillary grooves contained in the head and jambs of the frame. Grooves were sometimes added to the sash itself. The modernist movement embraced new materials such as pressed steel. In this building, steel doesn't seem out of place, even though set in a neoclassical facade. Meanwhile, in the suburbs, a pastiche of vernacular styles was popular. The 1960s high-rise buildings required improved window quality, as higher buildings meant increased wind pressure and exposure to rain. Horizontal pivot windows enabled cleaning from the inside. In the 1970s, aluminium windows became popular. Mostly single glazed, they were available in a variety of styles. They could be directly fixed to the jambs or set in a timber subframe. The volume house builders have always tended to use timber windows. They're available in a huge range of styles, often with the addition of imitation features to evoke earlier ages. Even with new materials such as UPVC, there's an insatiable desire to recreate the past. These glazing bars are false, and so are these timber sliding sashes. Window replacement is big business, but is often unnecessary on technical or environmental grounds. Serviceable windows are often replaced with whatever is fashionable at the time: aluminium, plastic, or even louvers. Modern timber windows are usually twin rebated. There's a rebate in the frame, and the frame itself is sometimes made up from smaller section timbers to save waste. A second rebate in the sash itself closes against the rebate in the head. In addition, there are numerous grooves.
They form different functions. First of all, we have a mortar groove to allow the window to be bed in if required. We have then relief V grooves, which reduces the tension and the possibility of the sill cupping because of the movement of the timber. And then finally a capillary groove, which stops water tracking along the bottom of the sill and will form a drip to allow the water to drip away. On the sash, again, we have a capillary groove or drip, a Euro groove, which is there to take the Spangalette locking system, and finally a groove along the length of the sash, which together with the groove in the fitting will give a decompression chamber when the window is closed to help with the weather performance of the window.
The majority of timber windows are made from softwood, timber from coniferous trees.
This freshly felled larch, you can see the heart of the timber and a series of rings growing out. This is the heartwood, and on the outside, the lighter coloured timber, the sapwood. The heartwood would go to the sawmill and be used for a variety of different purposes. It's useful timber. The sapwood is usually discarded, chipped to make oriented strand board, perhaps chipboard. The bark again will be stripped in the sawmill and be used for a garden mulch as a replacement for peat. On this particular larch there are 48 rings. So this tree was planted just after the Second World War. It's 48 years old.
In this mixed conifer plantation, the felling of selected trees, known as thinning, takes place at regular intervals. This varies according to species. The second thinning of the larch, at about 50 years, will allow the maturing cedar more space to grow. The forest managers select the trees to be thinned. Their felling and removal is usually organised by timber yard contractors who bid at auction for the timber. The discarded branches are left to rot on the plantation floor. The stumps of the thinned trees are treated to encourage biological degradation. There are various species of softwood, but they can be classified into two broad categories: whitewoods and redwoods. The former tend to be fast-growing, lower-grade trees, which, although durable, tend to be unsuitable for fine joinery work. Their main use is for structural timber and fencing. Redwoods, slower-going trees providing denser timber, are ideal for softwood doors and windows. Once the timbers have been cut to specific lengths, the bark is removed. It's sent off to be packaged and sold as garden mulch. In this modern, highly mechanised sawmill, the whole conversion process is controlled by two operatives. The first decides on the optimum cut of each log. The initial cut removes the sapwood and inevitably some heartwood. The planks are trimmed to remove the sapwood either side, which is then sent on to be recycled into various forms of particle board. Laser beams assist the operator in determining the optimum initial saw cuts. Timber is a high-volume, low-marginal profit industry, and wastage must be kept to a minimum. The usable heartwood is directed to a second operative who decides how to best attain sections of the required dimensions. The softwoods produced in this country are generally unsuitable for joinery quality timber. The temperate nature of the UK climate encourages fast growth. Consequently, the wide-spaced growth rings result in a relatively low-density timber. Most quality softwood is imported from Scandinavia and North America. The ecological costs of shipping need to be set against the sustainability claims of the joinery manufacturers. At John Carr's in Gloucester, selected imported redwoods are used in the manufacture of windows. Sustainable hardwoods for sill sections, thresholds, conservatories and even windows are mostly imported from West Africa. This softwood section, halved from an individual log, will form the sill. After being planed, cut to length and rebaited, the sill section is fed through a machine which cuts the end joints. Traditionally, this would comprise a square hole in the sill, known as a mortise, with projecting tenons on the jambs. With modern production methods and adhesives, a double-ended finger joint is more practical. This finish sill section has been through a second machining stage to form the correct profile. This includes weathering and drips to shed water, locating and anti-cupping grooves. This modern machine cuts all four faces of the profile in one go, work that would have required at least 4 separate operations in the past. Any minor blemishes to the profiled sill are identified for later remedial treatment. To produce the complex sill profile, a series of cutter blades have to be made. 4 identical blades are bolted into each circular cutter block. Establishing the exact profile of each cutting blade is easy using computer-aided design. These plastic profiles form a template which enable the operator to make a perfect copy in high-speed tool steel. The nature of softwoods is such that minor blemishes inevitably occur. Minor damage can also result from the machining process. A flexible filler is quick to apply and durable. In modern construction, most windows have finger or combed joints. These have largely replaced the traditional mortise and tenon, giving savings in both machining and assembly time. Unlike mortise and tenons, which are usually wedged or pegged, comb joints rely on the glue for their strength. A pneumatic press ensures the joints are tight and that the frame is square. Mechanical fixings ensure the frame remains in shape until the glue has dried. These sashes are made from a durable hardwood, timber from deciduous trees. Contrary to popular belief, some imported hardwoods are no more durable than softwoods. Both require preservative treatment. Once the sashes have been assembled, the complex grooves can be cut. Cutting the grooves before preservation ensures that all the exposed surfaces are comprehensively treated. Cutting the grooves after treatment would mean that the best preserved timber is machined off. This wastes preservative and is also a potential health hazard to the operatives. The preservation process uses highly toxic chemicals to prevent the growth of fungal spores and to inhibit the life cycle of insects which might otherwise attack the timber. A water-based timber preservative is applied to the timber components in controlled conditions. The use of a sealed tank and vacuum impregnation ensures the maximum penetration of the timber by the preservative. There's plenty of evidence to show that factory-preserved and coated windows have a longer life. A variety of paints and stains are commonly used. Here, a water-based primer is being applied to softwood sashes. The primer provides the initial weather protection layer and a good surface for subsequent coats of paint. Even greater durability can be achieved by completely painting the window before installation. If the window is not pre-painted, the vulnerable surfaces, those in contact with the masonry, only have the protection of the primer. In modern windows, the ironmongery is fitted after the windows have been primed, painted or stained. These windows are sliding sashes fitted with a proprietary slide and tilt ironmongery system. Most modern windows are hinged. Butt hinges are still used, although friction hinges are increasingly common. Friction hinges resist sudden movements of the window and are particularly important where heavy, double-glazed units are used. Some hinges are designed so that the outer face of the glass can be cleaned from the inside. Weather stripping is fast becoming the norm. It can either be a self-adhesive profiled tape, or better still, a synthetic rubber strip let into a suitable groove in either the sash or the frame. Most seals rely on compression for their effectiveness. However, their effectiveness can be reduced if painted over. Some seals are made from a material which actually sheds paint. Unlike their traditional counterparts, modern slide and tilt sash windows are not controlled by cords and weights. A spiral spring balance provides resistance to prevent the window sliding shut and at the same time reduces the force needed to open and close it. The ironmongery on these windows is quite sophisticated. It's designed so that the window can be swung right round for cleaning. In modern timber windows, the glass is usually secured by timber beads. These are not completely weatherproof and must allow for drainage. A self-adhesive profiled glazing tape can be applied to the frame rebate. Until recently, 14mm double-glazed units with two 4mm sheets of glass and a 6mm gap were standard. Nowadays, a 12mm gap, providing increased thermal and sand insulation, is becoming more common. This, however, requires thicker casements. Spacer blocks set on the bottom rebate allow water to drain from under the bead. Trapped water can damage the double glazing seals as well as the timber itself. Additional spacers to the side rebates allow for thermal movement, drainage and ventilation. The bead should cover the glass by at least 15mm to protect the double glazing seals from ultraviolet light. Some beads have an integral seal or gasket. An alternative is to apply glazing tape around the edges of the glass before the beads are fixed. Pressure on the bead while nailing ensures the seals are adequately compressed. UPVC windows have made steady inroads into the replacements windows market and are increasingly being used in new housing. They first became popular in the mid-1970s. One of their main attractions is that they don't require regular painting. However, it's probably too early to determine their durability long term, and unlike timber windows, piecemeal repairs are difficult. There are also some environmental concerns. The windows are made up from pre-formed sections, often reinforced internally with galvanized steel or timber. The sections are drilled to suit specific hinge and locking mechanisms. The mitered corner joints are heat welded in a special machine. This simple technique accounts for their popularity and cost effectiveness as replacement windows. Like modern timber windows, draft stripping applied to the sash improves their weather resistance. Reflex friction hinges are used here on these side-hung casements, although other manufacturers will offer alternative hinging systems. These particular windows are designed to be glazed from the inside. This offers improved security and better access should reglazing be necessary. On high buildings, the costs of access may be greater than the cost of the glazing. A strip of silicone secures the glazing in the rebate so that the glass can help stiffen the frame. In the UK, unlike the rest of Europe, it's common practice to position the windows before building the masonry. It's also common practice to set the window in the external leaf. Most standard windows have a small sill projection. The drip in the sill dictates window position, but setting windows in the external leaf makes them vulnerable to the weather. A vertical DPC prevents moisture travelling from the brickwork into the blockwork. The window itself is usually secured by 2 or 3 cramps built into the brickwork either side. Another potential problem with fixing the window in the external leaf is cold bridging, leading to condensation on the internal reveal. This can be resolved by locating the frame deeper in the wall. This usually requires a separate subsill because the drip on the sill is no longer proud of the masonry. Subsills can be precast or formed in brick or plain tiles. Even further protection can be provided by locating the window behind the external leaf, normal practice in Scotland. An entirely different approach is to use plastic extruded sections to fix the windows. These avoid the need for a DPC and avoid messy blockwork cutting. Whatever fixing methods are used, there's no doubt that timber will remain a popular choice for windows. Good forest management, responsible manufacturers and ongoing research should ensure their sustainability.